The following information you are about to view is about the construction of the elevator system in Francis Hall.
Before the elevator car is assembled, the shaft and rail track is installed into the building. Elevators are not assembled prior to arriving at the job site. Steel members that form the elevator car frame are fixed together within the elevator shaft, attaching the cable drum to the suspension cables, which is housed in the dome or the ceiling of the elevator. After the car is assembled, the automatic gate opener is installed. This is what makes the car doors open upon reaching the desired floor. Once the car frame and mechanical aspects are set in place, the interior of the car is designed and installed to meet whatever aesthetic appeal the owner is looking for.
The main component of the interior elevator is the microprocessor or computer. The three main things the computer must know is 1, where the people want to go, 2, where each floor is, and 3, where the elevator car is at that moment. The buttons in the elevator are connected to each individual floor wires through this microprocessor or computer. Passenger traffic patterns as well as load sensors are safety mechanisms used in an elevator. These will be talked about further on in this video. The two doors that are consisted of in this elevator are the car door and the level door. The car doors have clutch mechanisms. They're made of two panels who, when the door opens, they close and come together, and whenever it closes, they open up. And this unlocks the doors to access the individual floors. This is the same for the level doors.
The elevator car will be raised and lowered by traction steel ropes, which are looped around a sheave, which is a pulley at the top with grooves around their circumference, and attached on the other end to a counterweight. This counterweight should weigh about the same as the elevator car filled to 40% capacity. This balance will be there to conserve energy, so it would only take a slight force to tip the balance in one way or the other. Both the elevator car and the counterweight will ride up and down along guide rails on sides of the shaft. These guardrails are in place to keep the car and the counterweight from swinging around inside the shaft. And they would also work with a safety system to stop the elevator in the event of an emergency.
Elevators have 2 or 3 types of brakes. If there's an error in the safety chain, a clamp closes on the pulley above the car, preventing the elevator from moving. Unlike an automobile brake, which has to be depressed to engage, the elevator brake is clamped down unless power is supplied to release it. That means that any loss of power, either due to a system error or an electrical grid failure, will set off the motor brake. Elevator engineers also worry about more than just cable failures. The electronics, the pulley systems, and other features must be working to ensure safe travel. Most systems also have a load sensor in the car floor. The load sensor tells the computer how full the car is. If the car is near capacity, the computer won't make any more pickup stops until someone has got off. Load sensors are also a good safety feature. If the car is overloaded, the computer will not close the doors until some of the weight is removed.